This is a video of the solution to OCR FP3 January 2007 question 2, which asks us to take two planes, r dot 3i plus j minus 2k equals 4 and r dot I plus 5j plus 4k equals 6. Now it wants us to find the line of intersection of the two planes and give our answer in the form r equals a plus tb. Okay, there are a number of possible ways, and if you look in the answer scheme you'll see several. I'm going to show you a method that where we convert the two planes from their vector form into their Cartesian form and then solve those Cartesian equations simultaneously. So I'm first going to convert this plane into its Cartesian form, and it's really straightforward. You simply take this normal vector here and use these values as the coefficients of x, y, and z, and then the a dot n value here, 4 on the end, we'll simply put on the right hand side of the equation. So that first equation I'm going to write as 3x plus y minus 2z equals 4. And I've literally just read 3, 1, minus 2, and 4 and put them into there. This second equation is going to become x plus 5y plus 4z equals 6. So I'm just going to write that down. X plus 5y plus 4z equals 6. Now, you'll remember from FP1 that the way to solve sets of equations where you've got fewer equations and variables is to take one of the variables and set it equal to a parameter t. So I'm going to say in here t is going to be my z variable. So I'm going to rewrite these two equations using this, and the first one then becomes 3x plus y minus 2t equals 4, and the second equation becomes x plus 5y plus 4t equals 6. Now, we're going to solve these simultaneously, and obviously the first thing to do really is to multiply this second equation by 3. So let's label up these equations properly, and now we're going to rewrite another equation here, 3, which is going to be equation 2 times by 3. So that's going to become 3x plus 15y plus 12t equals 18. Then I can subtract these. I'm going to subtract equation 1 from equation 3. So this is going to become equation 3 minus equation 1. And that's going to be nothing for the x. That's the whole point of that. 14y. 12t minus 2t is 14t. And then 18 minus 4 is 14. First thing we can see is we can quite easily divide through by 14 here and get ourselves y plus t equals 1. Now, we'll be using this in two different ways. At some point we're going to need a y, this y as a subject, and then another t as a subject. So I'm going to write both of those over here. So I've got y equals 1 minus t, and t equals minus y plus 1. Now that I've got that, time to substitute it back into one of these equations up here. So I'm just going to substitute it back into equation 1 here. So equation 1 is going to rewrite that as 3x. Now this is where we're going to need y as the subject. 3x plus 1 minus t minus another 2t equals 4, and that's going to get me 3x equals 3t plus 3. I'll just move the paper here a bit. And so we've got 3x equals 3t plus 3. Divide through by 3 again. I'm going to get x equals t plus 1. So I've got my equation in terms of x there. I'm going to rearrange that because I'll need it later with t as the subject. So t equals x minus 1. Now, I've got three equations now. T equals z, t equals minus y plus 1, and t equals x minus 1. So I'm going to equate those three together and write them out like this. So I've got t is equal to x minus 1 equals minus y plus 1 equals z. And we're getting close to our final solution, but that's not the form you'd normally see the Cartesian equations of a line. And so I'm going to rewrite them again as x minus 1 over 1, exactly the same thing. Now I'm going to want y with just y on its own, positive y. So I'm going to rewrite that as y minus 1 over minus 1, which you should be able to see as exactly the same thing. Just put it over 1, multiply top and bottom by minus 1. And this one as z minus 0 over 1, which may look a little redundant, but it's going to help us read the equations back into the vector form, which once they're written in this form is really quite easy. We've got r equals, now the position vector for our line, at any point on the line, is given by these numbers here in the numerators. So it's going to be 1 there. Remember, it should be x minus a over m is the kind of standard form for that. So I read 1 there, a 1 for that y, and a 0 for the z, plus t times the direction vector. And the direction vector we simply read from the bottom here. So it's 1, minus 1, and 1. And that is the vector equation of the line of intersection of the two planes. Thank you.